Hey math kids, today we're going to talk about the unit circle. And so what the unit circle is, it's a circle that has a radius of 1. It's centered at the origin, and it's how we really dive in deep to trig functions. And so the way that the unit circle is generated is we make a radius of the circle, and then where that connects to the circle, we drop down and we look at this, and it's x comma y at that point, and that can tell us a few properties. Now it's a right triangle, so we can look at our right angle trig functions that we've studied in the past: sine, cosine, and tangent. And so this side we're going to call y, this side we're going to call x, because the length of it goes to that x value, and the length of this goes to the y value. And then the hypotenuse we're just going to call 1, because it's a radius of the unit circle, which is just 1. Okay, now if you remember SOHCAHTOA, if we do sine, and we're calling this angle theta, sine is opposite over hypotenuse, so that's y over 1, which is just y. Cosine is adjacent over hypotenuse, so it's x over 1, or just x. And then tangent is opposite over adjacent, and so that's y over x. Now you're going to want to just memorize that. So I'm going to get rid of these things in the middle. So sine is y, cosine is x, tangent is y over x. That's going to help us a lot with any trig stuff that we run into, okay, with the unit circle. So some other properties, we see that the highest value possible on the y-axis on the circle is 1, and the lowest value is -1. When we start rotation, we start here, so this is considered 0 radians. It would also be 0 degrees. And then as we rotate, we go 90 degrees or pi halves, depending on how we do it. Half a circle is 180. It's also pi. This is 3 pi halves, or 270 degrees. And then when we get back here, we've gone a full circle, so it's either 2 pi or 360 degrees. Okay? All right, we'll talk a little bit more about this as it comes up, but I think that's going to get us through thing. One more thing to notice: since sine is y and cosine is x, tangent can be written as y, which is sine, so tangent can be equal to sine theta over cosine theta. Okay, and then just for good measure, I'm going to remind you about the Pythagorean identity, which is this. So all those might come in handy when we're dealing with trig functions in the future. Okay? All right, let's just try an example and see what happens, and if I need to explain anything else, I will explain it in the context of that example. So it says state the exact coordinates of P and Q. So what we're going to do, there's a diagram, has the unit circle, and let's see, the measure from here to here is -72 degrees, and then the measure from here to here, I think, actually having a hard time reading this, exactly what they're talking about though, but I think they're saying the entire distance from here to here is 157. Okay, so from there to there. Okay. And it says state the exact coordinates of P and Q. So P is right here, Q is right here. And so if we're looking at P, we want our x comma y value. And if you remember, cosine is x and sine is y. So it's really asking for the cosine comma sine value. So what we're going to do for P, we're going to just plug in this angle, 157, and we're going to say cosine 157. I want to go to mode and make sure that I'm in degrees because I'm plugging in a degree measure. And then I get negative 0.921. Yeah, because we want to do 3 significant figures. So we get negative 0.921 for the x value. And then for the y value, we do the same thing. We just say sine 157. Once again, check that you're in degrees if you haven't already. And that's 0.391. 0.391. Okay. Now we're going to go to the other one, and we're going to do the same thing, but we're just going to plug in a negative 72 instead. So cosine negative 72, hit enter, and then sine negative 72. And so the x value is 0.309. And then the y value was negative 0.951. Okay, so that's the value for Q, or the point for Q, and the point for P. Once again, it's just stressing that sine is y and cosine is x. Okay, and that should be it for that section. If you need additional help, please come to Math Lab. Until then, calculator.